Welcome to School of Next Gen. Today's video, the main topic is review and revision. So, SSC or class 9 and 10, all together, we have to complete the physics books within a very short period of time, right? So, very first chapter, physical quantities and measurement. And obviously, this is the NCTB curriculum, so I'm going to use some Bangla language as well. And this is actually dedicated to English version. That's I'm talking here in English. So, physical quantities and measurement. Very fast, we have to understand the definition of physical quantities, right? Like length, of course, L, and unit is meter. Same as electric current flow, symbolized by current I, and unit is ampere. Same as volt, unit is volt. Resistance, ohm. And if we are talking about the specific resistance, the unit will be ohm meter. Such as we have to know all the unit and their dimension as well. Say acceleration, unit is meter per second square. So what will be the dimension of acceleration? Meter is length, so L, and time is t, so square. So this is the dimension of the acceleration. And of course, we have to know the scientific notations because we have to solve some numerical problem as well as some determine whatever. So in that case, we have to have a very good idea about scientific notation. And of course, when we are covering the MCQ questions, and we have to have a very good knowledge about the scientific notations. Afterward, there are some instrument in physics because we have to measure some quantities, measure something like the volume, right? So to determine the volume, you have to the theoretical knowledge like length, breadth, and the height. So if you multiply all these three physical quantities, so you will have the volume. So unit will be meter cube, right? But if you have a sphere or maybe a particular rod, so you have to have the knowledge about slide calipers or maybe screw gauge. So by use this instrument, you might understand or you might calculate or determine the radius of this sphere by the use of slide calipers and as well as the length of this rod. This is very basic about the very first chapter, physical quantities and measurement. Mostly students prefer this chapter to complete only the MCQ. So in that case, my recommendation is to go through all the chapters like 5 to 20 minutes and summarize all the important points from the books, and that's it. But I will recommend something for measurement. I mean, you have to attempt some CQ questions as well. I'll go through details in my second part video. The second chapter is motion. Here mainly we are talking about speed, velocity, acceleration, etc. And of course, within the motion, there are a couple of equations we have to understand, like the distance. So distance, the very basic equation is ut plus half at squared, where s is the distance, u is the initial velocity. Say there is an object. So this object have got an initial velocity is u, and when it's have a acceleration is a, and it will reach some extent up to this length. So this is the distance s, and from A to B, it will take a time t to traveling from A to B, right? So the equation will be S. Same as there is another equation where we could write down v square equals to u square plus 2as. Here, very important and fundamental things is which equation is implicable or applicable for which numerical problem you have to solve. It's need to be very precise concept, which is more practice and more perfection have to be done by yourself. And another one is acceleration, of course. So acceleration is v minus u by t. And there is another equation, s equals to ut plus v, u plus v over 2 times t. So this equation is very important and covered within the second chapter. And of course, there are some graphs we have to learn because of the MCQ and CQ as well. So this is actually time versus distance. So here up to this distance, like within a certain period of time, it travels some distance. Here is distance versus time. I will explain later on in my part 2 video more about this motion chapters, MCQ and the graph. Chapter 3, force and Newton's law. So force, right? As an example, here is a particle. If we apply a force, then it will achieve acceleration, and of course this object have a mass. So Newton's second law, it's saying F equals to ma, where m is the mass and a is the acceleration. Sometimes explanation type questions or comprehended question, which is in B number question, might ask what is 50 Newton. So what does it mean by the 50 Newton? So the mass of this object is, say, 10 kgs. So 10 kgs. And if we applied here 50 Newton of force, so it will achieve 5 meter per second square. So here is 50 Newton. It means the value of F equals to m into a. So m is 10, obviously 5 is equals to the acceleration. So we can define a 10 kgs object applied force of 50 Newton achieved 5 meter per second square. Or maybe we could write down 2 times 25. So 2 is the mass or 25 is the acceleration. It's depend how you're gonna explain. So might be some MCQ also asked, or say there is a question what is 50 Newton, and there will be 4 options. So one options is 2 kgs, 25 meter per second square, the acceleration. Here maybe 5 kgs, and of course here 10 meter per second square, or maybe 10 and maybe 5, etc. So this type of question might be asked within the chapter 3. And as we know, for SSC or any types of questions in standard 10, the question has to be combined, right? So some portion from the second chapter and some portions from the third chapter, or might be fourth chapter, all combination can be within a question, might be appear in the question. So we don't need to be focused just one chapter for one questions, right? Anyways, and of course, the second portion of the third chapter is Newton's law. So Newton has three law. So very first law, what it's saying and how we explain this three law. The very first law said object like to stay the way they are rest or motion. It means if there is an object, it will remain static until unless there is an external force applied. Vice versa, an object, this one is moving, it means it has a velocity, say 5 meters per second. It will continuously moving until unless there will be an external force applied to stop it. And very second law is saying the force is equals to m into a. In some other way, we can say the force is equals to how hard you push times how heavy it is, right? Third law, every single force will have an opposite but equal force. It means that if you give a force here, same amount of force it will repel towards you. This is the second law. And of course, within these three laws, there's some extended or maybe explanation question might ask in your exam. Afterward, let's use a different pen. Let's use the white one to understand more. No. Use the black one. Okay. So next topic will be inertia. Inertia. What is the definition of inertia? Inertia is a tendency of an object to resist any change in its state or maybe motion, rest or movement. And this is actually the first law of Newton. Maybe a passenger launches forward. When a car suddenly stops, it will feel inertia. Anyways, so within the inertia might be some MCQ or might be explanation question might become within your question. Anyways, afterward, a very important and my very favorite one is momentum. So what is momentum? Momentum, define P is equal to mass times the velocity. What will be its unit? So unit will be kgs and meter per second. Okay, let's try here. The student who are going to appear the SSC, let's try the dimension of momentum. Okay, this is your homework. Afterward, let's say, okay, another topic is impulse. So impulse is denoted J is equals to change in momentum. Change in momentum. Change in momentum. So change of momentum, or might be we could write down. So momentum is mv. So we could write down m v2 minus v1, right? And what is the unit for impulse? So this is kg and meter per second. So impulse and the momentum unit would be same. But if question asked what is impulse force, right? What is impulse force? So impulse force is equals to F times T. Here F will be more, so F will be more and T will be very less. So more amount of force can be applied within a very short period of time. This is called impulse force. Say there is a nail and you are going to hammer on the nail. So the force applied on the nail is an example 100 Newton and the time is very short, say 0.1 second. So if we put through the value of 100 Newton times 0.1 second, so it will be 10 Newton second. So this is the impulse force. Afterward, another very interesting topic is law of conservation of momentum, right? In that case, you have to have this equation m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. By using these equations, you can calculate, say example, there is a vehicle or a particle. So this particle, if they collide within this place or within this area, what will be the final velocity? Or, by the way, obviously it has a mass. Obviously it has a mass and initial velocity u1 and u2, and the collide velocity or the together velocity will be v. Or maybe there is a vehicle and there is a vehicle and they are collide here. What will be the final velocity of this vehicle? It might be asked within the question. There are various types of question might ask within this equation. Anyways, we have to learn these types of math as well. It is very important for us. By using law of conservation, we can find out the value of, say, there is a gun. So there is a gun. If you fire a bullet, you can calculate the recoil velocity of the gun, right? So in that case, the bullet has a very initial velocity, say u equals to 200 meter per second. Obviously bullet has a mass and the gun also have a mass. And what is the recoil velocity? This thing also can be calculated by the law of conservation. Chapter 4, what we have learned. So say there is an object and it displays up to here. So obviously we have to apply a force on the particle or the objects. And of course, when we applied on an object here, work done achieved. So we could write down the work done is equals to force times how much displacement by the object or due to the force. So this is the work done, right? By this equation or by this topic, we can learn the friction. So say there is an object. If you applied a force here, and of course this object is on a floor or on a surface, maybe smooth or maybe not smooth. Anyways, this surface obviously it will appear a force, and this force is called the frictional force. And of course you have to know the value of mu, which is the frictional function. Anyways, afterward, you have to have a very important topics within this chapter, that is power and the energy, right? So energy is actually two types. One is potential energy, another one is kinetic energy, so potential energy, ep, is equals to mgh, and kinetic energy is half mv square. So here you can see the height is appear within this equation. It means here is a building, and of course it has a height, and if you throw, or you yourself as well, if you fall down from this top of the building and you need to travel the height of h, and of course when you fall down from somewhere, their acceleration due to gravity appears, and of course you have a mass. In that case, the potential energy is mgh. There's lots of explanation actually. When I'm going through more details, I'll explain more details. And here, say you need to travel, or you need to climb a mountain hilly path, right? In that case, of course, this is you have a mass, of course, and to travel this distance you should have a velocity, right? And in that case you should have a kinetic energy, and ek is equals to half mv square. We also explain this equation in various ways, just I'm giving this very short explanation here. Afterward, power is equals to energy over time. Say you have two brothers, yourself, you are Uzan, and your brother is Unan. So your energy is 20 joule, and Unan also have the energy is 20 joule. You are twin actually. Anyways, and your energy also similar. But you complete any task by 5 seconds, but your brother can complete that work by 10 seconds. So whose power is more? Let's try. P is equals to 20 over 5, so it will be 4, and here P is equals to 20 over 2, so here will be this will be 10, so it will be 2. So unit will be joule per second, here will be joule per second. So the very convenient and very used unit for power is watt, W-A-T-T, or maybe W is fine. So 1 watt is equals to joule per second. Next topic is efficiency. So you have got the energy and you have the power, but how you solve a problem very effectively, that is called actually the efficiency. So efficiency is denoted, eta is equals to output power over the input power, right? Let's give an example. Here is a system. This is a system, So to complete this system, like I'm using this recording by using a computer and some other instrument, whatever. So all this thing is a system. I'm giving an input and here is the output. So let's give an example. I'm giving 100 watt as input, but I'm getting here 70% output. It means that I'm giving you another way. The example might be, say, I'm recording this video for my students and I'm giving lots of labor, I'm giving lots of consistency, but the view is very less. Indeed, my output is 70%. So how much effort is lost? Here is 30%. So what is the efficiency? Efficiency is equals to 70. So output over the input times 100%. So this will be 70% and 30% is lost. This topic is mechanical energy or the total energy. So mechanical energy or the total energy is equals to, at any point or any place, the potential energy plus the kinetic energy is called the mechanical energy or the total energy for that point. Give an example here. At a point, of course, here a potential energy roughly mgh, right? And of course here we have a kinetic energy as well, though at the vertex point or the top point the kinetic energy is 0, doesn't matter, but we have a kinetic energy. So E plus Ek will be the mechanical energy at A point. Same as at B point, obviously here will be Ep plus here will be Ek. So the total energy will be mechanical energy for the point of B. Why here, by the way, the kinetic energy at A point is 0? Because here the topmost point, the velocity is 0. That's why the kinetic energy is 0. Lots of questions might be asked when I'm going more details during the covering the chapters. I will explain. Chapter 5th, gravitation, right? Here we have to know about gravity and gravitational force. So what is gravitational force? Gravitational force, F is equals to K or of course G. Two objects mass, one is m, another one is m, and the distance is d square. It means that here a object, here is an object, and in between these two object, and of course this will have a mass m and another one will be small m, doesn't matter, you can write down m1 m2, same thing, and the distance between these two object or two particle, that is d, and g is the constant. So value is 6.67 into 10 to the power minus 11 Newton meter square per kgs. So by using this equation we can have lots of problem solving. From the Newton's law, which we learn, like F is equals to G. So as I said, we can also write down m1 m2 over d square. From this equation we can define the acceleration due to gravity G is equals to gm over the r square. Here r is the radius of the earth, and from this equation we also can define, or we can also explain the variation of g with the height. So if the acceleration is z and the height is h, so we could write down g is equals to g times r over r plus h whole square, and h is the height, as I said. So here maybe somewhere at h height, the acceleration due to gravity, and this g is acceleration due to gravity at earth. So we can find out where we would like to have the acceleration due to gravity, this one, by using this equation. Anyways, if this height is very small compared to the radius r, in that case we could write down g of h is equals to g times 1 minus 2 of h over r. This equation can be used to solve some numerical problem as well. So from the chapter 4, we already have 3 equations. One is F force, another one is acceleration due to gravity, another one is somewhere you would like to calculate the acceleration due to gravity. Now, if you'd like to calculate the acceleration due to gravity at the depth somewhere inside the earth, in that case equation can be assembled as g times 1 minus d over the r. So this d is nothing but the depth, right? And if this is the earth, so at the center d is equals to r, where g is equals to 0. In that case, g of depth is equals to 0. Chapter 6. Chapter 6, the main topic is pressure, and of course pressure in fluids. Here we can understand the basic theory of pressure is equals to F over A. It means here is an area. If we applied a force here, and of course the area is A and force we applied F, so F over A is called the pressure, and the unit will be Newton per meter square. And Newton per meter square is equals to 1 Pascal, or maybe PA, same things. So this is actually chapter number 5, where we are going to learn actually the pressure. And if there is a container, and if you consider the height of the container is h, in that case, at the bottom, I mean from top to here, h distance, what will be the pressure of the fluid or the liquid? It will be P is equals to H rho G, right? And of course we are going to use this equation and we can solve some numerical problem. And of course, if we could calculate the force as well, how we could calculate the force at here, let's see. We know P is equals to F by A, so we could write down F is equals to P times A, and what is the value of pressure? So it will be H rho G times A, right? So A is the area and H is the height. So this is say a cylindrical container, so it will be A. In that case, H time A is V volume rho G. And what is rho? Rho is the density of a liquid or a fluid, so it will be the mass of the liquid and of course the volume, right? So if volume is increased, so the density will be decreased, and if it is increased it will decrease, and if it is decreased it will increase, right? Another very important fact, that is 1 atmosphere, right? This is also the unit of a pressure, and 1 atmosphere is equals to, we could write down 101,325 Pascal, or we could write down 1 times 10 to the power 5 Pascal, or we could write down 10 to the power 5 Newton per meter square. Afterward, there is a very important MCQ, right? Barometer, right? Barometer. So barometer is an instrument to measure pressure, and mainly this barometer is used to measure the atmospheric measure. Afterward, Archimedes principle. Archimedes principle. Archimedes principle say there is a box. So if we give a pressure here, and same amount of pressure will be realized here, here, and here as well. And of course, by using this Archimedes theorem, we have some numerical problem as well to solve by Archimedes theorem. Now we are going to understand a bit of buoyancy force. If there is a obstacle or there is a object on water, and obviously the weight of the object, so this is actually a boat, so when we keep on water, so there will be a force which is actually the weight of this boat towards this direction, say this is W, and of course the water will give another force upward, and this upward force actually the buoyancy force, right? So from the concept of buoyancy force, we could write down if buoyant force is equals to WEIGST, weight of displaced water minus, or actually equal, we could write down rho times V times G. So if there is a container and full of water, and if we keep a object here, so due to the weight of the object, same amount of water will fall here. This is actually the very basic concept of buoyant force. For chapter 6, the very important topic is pressure. So pressure is equals to F by A. The unit of force is Newton and area will be meter square. So the unit of pressure is Newton per meter. Literally, the very used unit for pressure is Pascal. So 1 Pascal is equals to 1 Newton per meter square. Afterward, there is an important topic that is called Pascal law or Pascal principle. Pascal principle. It postulates that any pressure change in a confined container or any confined place, incompressible fluid is transmitted equally and without loss in all directions throughout the fluid and the walls of its container, right? It means that if this is a container and, for example, if I push or if I placed a pressure here, and obviously a pressure will be realized here as well. And obviously this container is confined and the pressure is going through within this direction. This is a very simple word I've explained here. By using this principle, the practical experience or used can be hydraulic pressure. So this is actually the hydraulic pressure. Here a force or pressure can be imposed, and obviously here another force or the pressure can be realized within this piston, right? And here is F1 and here is F2. This is the smaller piston and this is the larger piston. And this flange area is A1 and obviously the diameter is D1. Diameter actually here, the diameter of the piston is D, and here obviously the distance from this top portion of the flange up to this direction is D1, and here as well D2, not mentioned. Anyways, it not necessary. And the smaller piston pressure is P1 equals to F1 by A1 and F2 is equals to F2 by P2 is equals to F2 by A2, and obviously we could say that P1, the pressure imposed here, is equals to P2. From this equation we actually found F2 is equals to A2 by A1 into F1. By using this equation we can solve a couple of numerical problems. Here is an example. Say the smaller piston pressure F, and here obviously another pressure will be F2. And the very first question, area of a ram. So this is actually the ram. So the area of ram we have to find out, I mean how much area could be here. So the equation for pi by 4 d square, and we actually have got the value of d from the question. As I'm not placing the question here, doesn't matter, just we need to go through how to solve this types of problem. And another one, the area of plunger, I mean the smaller one, we have to find out the value of the smaller piston area. In that case, same equation, pi by 4 d square, and obviously we have got the value of d here, which is 0.028, and that will be whole square. So we'll get the smaller piston value and the larger one, which is called ram within this question. Afterward, the intensity of pressure due to the plunger. So what does it mean? It means here how much pressure can be imposed. That is the question. So the equation is F equals to F by A. So the value of F is given by the quotient, that is 380 Newton. And the area we already calculated here, the smaller plunger or the plunger, that is 6.157 into 10 to the power minus 4 meters square, that plugged in here, and obviously we'll get the value of the intensity pressure due to the plunger. We already know the unit of pressure is Newton per meter square. Newton per meter square is equals to 1 Pascal or maybe Pascal, right? So this is actually the unit of the pressure, but sometimes we could find the unit of pressure is 1 atm. It means atmospheric pressure, right? So 1 atmospheric pressure means 101,325 Pascal or meter per, or maybe you could write down Newton per meter square, right? Meter square. So we could write down 1 into 10 to the power 5 Pascal or Newton per meter square. Same things. So we could write down 10 to the power 5 Newton per meter square or maybe Pascal. So this is actually the relation between the atmosphere and the Newton per meter square or Pascal, right? But 1 atm is equals to, we could write down 760 millimeter mercury. So this type of conversion, I mean from 1 atm to how much millimeter of mercury pressure, and if we could write down the centimeter mercury pressure, this is your task, you have to find out here. Anyways, here the another topic is Archimedes principle, right? So Archimedes principle states that an object submerged into the fluid experiences an upward buoyancy force which is equal to the weight of the fluid that displaces, right? It means that the principle said this object is submerged within the fluid, right? And due to submersion of this object, a fluid experiences a buoyancy force which is actually 2 kgs, right? And same amount of water will fall down here. As I said, the amount of upward buoyancy force which is equal to the amount of water that displaces from the container. Or maybe another word, we could say the upward buoyancy force that is exerted on a body immersed in a fluid, whether partially or fully submerged, is equal to the weight of the fluid that the body displaces and act in an upward direction at the center mass of the displacement, right? Displaced fluid. So this is the basic postulate of the Archimedes law. By using this Archimedes law, we can solve a couple of problems as well. What we can solve by the use of Archimedes principle, first of all, the density. What is the definition of density? Density is nothing but the mass over the volume. So unit of density will be kgs over meter cube, right? And the mass is equals to density times the volume, and the weight, right? So the weight is equals to the mass and the acceleration due to gravity. It means that if we could write down W is the weight of water or fluid whatsoever is equals to the mass and the acceleration due to gravity. And obviously the weight of fluid or water, mass and the acceleration due to gravity, right? And what is the definition of mass? Mass is equals to density over the volume, right? So we could replace instead of the mass, that is rho times the volume and the acceleration due to gravity. So weight is equals to volume rho g, right? And this is actually the thrust force. It means that this is the liquid and there is a substance. This is actually a ball. So the weight of the ball will introduce a force, that is gravity, and the water actually given the thrust force, that is upward direction. And this thrust equation will be rho v and the acceleration due to gravity. Here are three important things we can conclude here, how it's actually worked, this Archimedes principle. First of all, when increased the pressure within a fluid increases with depth, so submerged object experiences greater pressure on the bottom than the top. It means this is the container, right? And obviously this is the height from top to bottom. So at the bottom the pressure will be more. It means that the pressure is equals to H rho G. By the way, this pressure P is equals to H rho G, and what will be the force? So we could write F is equals to the empirical equation is P is equals to F by A, right? So F is equals to P A, right? So P is H rho G times A, right? So this is the container, and obviously all the container where we actually keep the fluid or water looks like the cylinder, right? So this is the area of the cylinder is A and height is H, right? So H times A is actually the volume. So we could write down the H times A is V rho G. This is actually the thrust force as well. And the second point, the net upward force. This pressure difference creates a net upward force, and this net upward force actually the buoyancy force. Due to the buoyancy force, actually the object either float or maybe submerged or sink, whatever, same things. So the buoyancy force is very important, and the buoyancy force actually the reason whether the object is float or sink. And the third point is weight of displaced fluid. The magnitude of the buoyancy force is equal to the weight of the fluid that the object has pushed out of the way. Whatever we discussed right now, these 3 points can be the extensive version of Archimedes' law. The very last topic is Hooke's law, right? Hooke's law states that the force needed to extend or compress spring by some distance is directly proportional to the distance, right? It means that the force is directly proportional to the distance. How much? So say this is a spring, right? So if we hang an object, so let's say this is the object, as a result the weight or the force will apply, and from here it will extend up to this distance. In that case, as I said, by the postulate, the spring, the distance is expanded, which is x, and the force will be directly proportional. And obviously we could write down minus k of x, and this is very important to know why the constant is minus. Okay, if you haven't got any doubt why this minus k here, please make a comment. I'll explain in your next video. And of course, from the Hooke's law, we could write down Young's modulus is equals to stress over strain, right? So what is exactly stress? Stress is nothing but the pressure, and strain is actually, say there is an object, if you press it or maybe expand it, whatever, its original figure or shape will be changed, right? Either increase or decrease. So basically there is a very important thing, why it is increase or not decrease. So you have to understood this fact. Anyways, I'm just saying, so let's say the length is increased. So this is the increased length, and before it was L, right? So strain means the increased length over the original length. And what is the definition of pressure? Of course, F by A over L by L. So we could write down FL by A of L, and obviously there is no unit. And by using this equation, we could solve a couple of problems. I'll explain later in my next video. And next video, I promise to you that I'll make chapter-wise video and try to make each of the chapters very concise and very precise at the same time, which is very hectic to me. But let's try. And please tell me whether I'm going to give the lecture in full English or maybe I can use some Bangla as well. Take care, and I'll upload very shortly the second part from chapter 7 to 14. See you. Take care.